So in general we can say that as we go till n here, we can take n and n common here, right? And we can get this much composite numbers here, but as we do n plus 1, so can we get n plus 1 factor among any of these? It depends on whether this n plus 1 is a prime or composite. Well, if it is a composite, then we may get a factor here also, right? If it is a factor of 6, if it may be a factor of 8, if it may be a factor of even a prime number like 7, and we have 7 here, right? So we can get it common from here. So and this will continue until we get a new prime number after n factorial. So we can generalize only one thing, that from n factorial, from 1 factorial n factorial till n factorial plus n, we can get consecutive composite numbers for sure, right? They will all be consecutive, right? n factorial plus 1, sorry, from n factorial plus 1 till n factorial plus n, we can get consecutive numbers, consecutive composite numbers for sure. But from that onwards, from n plus n factorial plus n plus 1, right, the trend will break, and we can get n plus 1 common from these factors. But if it will be a prime, then we cannot get any common. Thus the taking of common from these both expressions will continue until we get a next prime number, right, after n factorial. See, before n factorial, we may have n factorial minus 1, the numbers I am saying, n factorial minus 2. Let us say n factorial minus 2 was a prime number. So after n factorial, the taking of common terms out will be continued till we get some n factorial plus a, which will be a prime number after this, right? So till there we can get as many as composite numbers consecutive as possible. So the only thing that is generalized is that if we take n factorial, and we did here n factorial, if we take n factorial plus 1 as a number, and after on we can take n factorial plus 2, right? We can take 2 common, then 3 common, then 4 common, and we can take here n factorial plus n also. So minimum these much composite numbers consecutive we can get between n factorial and n factorial plus n plus 1. So we can say that between 8 factorial and 8 factorial plus we can say 8, yes, between 8 factorial and 8 factorial plus 8, we can get minimum of 8 composite numbers consecutive, right? As we can see, we can take 8 factorial plus 1, which is a composite, 8 factorial plus 2, which is a composite, and 8 factorial plus 8 is also a composite. So 1 plus 1, 2, 3, 4, like this we can get 8 consecutive composite numbers. So we can get as many composite numbers consecutive as possible, like as if you see, I am taking 20 here. So we can get 20 composite numbers consecutive, right? If someone asks that how many consecutive composite numbers can you get in the whole number line, so we can get as many as possible, because any number, let us say we want 2000 consecutive composite numbers here. So we can write 2000 factorial plus 1 plus 2 plus 3 plus 4, and 1 is I don't know whether 2000 factorial plus 1 will be a composite or not, but for sure this will be a composite number, because 2 can we can get 2 common here. So 2000 factorial plus 2 plus 3 plus 4, and we can go on till 2000, right? And then what we will get, that will be depend upon if it is a prime or a composite. So as we can see, we can get 2000 composite numbers here. So this way we can prove that we can get as many composite numbers consecutive as possible.